Okay, so guided practice for 521. Example 1. How far and in what direction does the point P, X, Y move when it's translated by the function T2410? So what we're saying is the transformation 2410 on the point X, Y. Okay? And so what that does is that equals, you would take the 24 and you apply it to the X. You take the 10 and you apply it to the Y. So we're talking about X plus 24 and then comma Y plus 10. So what does that do? Now it says how far and in what direction. So we go 24 units right and 10 units up. That's it. That's all it's asking you to do. Identify what happens to that point based on that translation. Okay? All right. Now, number 2, using the definitions described earlier, write the translation 5.3 of the rotation 180 degrees in terms of the function f on x and y. So we have a rotation of 180 that is applied to x, y. And then on the outside of that, we have a function t, right, which is 5.3. So what we really have is t5.3 of the rotation of f of x. So in other words, we have t r f of x. That's really what we're doing, right? That composition. We're putting multiple things together. All right. So the first thing we're going to do is we're going to use those rules to do the rotation part. Okay. So the rotation part, if you go back to the notes and videos previous, it said that, the rotation of 180 basically takes your x and y and makes them both negative, right? Assume that x and y are in the first quadrant. If you rotate 180 degrees, that takes it to the same exact place it was, but in the third quadrant, okay? So like 1, 1 would rotate 180 degrees would become -1, -1. All right, so that means we have, I didn't need that. We have -x, -y. Okay, and now we work our way outside. So now we're going to go to that translation. So we're going to apply that 5 and 3. So that becomes -x plus 5 and -y plus 3. Okay? So we're applying multiple transformations without actually having to graph it. Now, if you wanted to graph that and see it happen, then just pick a point on the graph and apply each of those rules separately. Okay? Do the rotation first and then do the translation. All right? So the next one, using the definitions described earlier, write the reflection over y equals x of the translation 2, 3 of the reflection over the x-axis of xy in terms of the function s of xy. So we're talking about doing lowercase r. We'll do it ry equals x of t2, 3 of r x-axis of s of x. Yep. Nope, one more. We have 4. All right, so we have a lot going on here. Now, s of x is just a basic point, right? So we're talking about x, y. So we're going to do all these things and work our way from the inside to the out. So the first one, we're going to do a rotation reflection over the x-axis. Now, if you go back to your rules, again, it's worth going back to the rules on this. the reflection around the x-axis takes your x and y, keeps in the same place, but the y value becomes negative. All right, so that becomes x negative y. Okay, then we're going to do a translation, right? So t 3 on that. And then after that, we got to do the last reflection over y equals x. Okay? So, translation, we add, so that becomes x plus 2, and then negative y plus 3. And then we're going to do our last transformation, which is ry equals x. And again, the rule in that reflection over that line, the diagonal line, y equals x, means you just take your x value and your y value and swap them. So you're going to take whatever's in the x position, which is all this, and whatever's in the y position, and swap them, which means we end up with negative y plus 3, and then x plus 2. That will be your final point after all three of those transformations. Okay? And that will be your final answer. All right, so we'll stop there.